In this video, we will be solving quadratic equations using the quadratic formula. We will only be focusing on equations that have rational solutions. After watching this video, you should be able to identify the types of solutions using the discriminant, and you should be able to solve a quadratic equation with rational solutions using the quadratic formula. The first thing that we need to talk about is the standard form of a quadratic. When we are solving quadratic equations, we need to have the equation written in standard form, and many times it does not start in standard form. In standard form, you will have the quadratic term ax squared, where you have a coefficient a in front of x squared, plus the linear term bx, where you have a coefficient b in front of the x, and then a constant c, and all of this must be equal to 0. Once you have your equation in standard form, you can use the quadratic formula. This is a formula that you need to memorize, and the formula will find the solutions to that equation. When we say solutions, we mean the value of x that will make that equation true, and the solutions will be negative b plus or minus, you'll have two solutions, then square root of b squared minus 4ac all over 2a, where that a, b, and c came from our standard form, ax squared plus bx plus c equals 0. You'll notice that the a is in the formula twice, the b is in the formula twice, and the c is in the formula once. When solving a quadratic equation, there are three types of solutions. You might have what's called a rational solution, an irrational solution, or an imaginary solution. We can actually tell what type of solution we're going to have without even solving the quadratic formula. The discriminant is a special name that we give to what was under that square root, the b squared minus 4ac. If the discriminant is 0 or a perfect square, you will end up with rational solutions. The perfect squares are those values where you take the square root and you get an integer, such as 1, 4, 9, etc. If you're not sure if you have a perfect square for your discriminant, all you need to do is take the square root, and if you get an integer, then that was a perfect square. You will get irrational solutions when the discriminant is positive, but not 0 or a perfect square. And then finally, you will get imaginary solutions when your discriminant is negative. Our first example, example 1, is to solve the equation x squared plus 6x minus 10 equals 30. So the first thing that we must do is to have our equation in standard form. Our standard form had to be equal to 0, so we're going to subtract 30 from both sides of this equation, which will give us x squared plus 6x minus 40 equals 0. Now we're in standard form. We can determine what type of solutions that we're going to have. So let's identify A, B, and C. A is in front of the quadratic term. So in this case, we have a 1 for our A. B is in front of the linear term, the x term. So here B is 6, and C is the constant. In this case, it's negative 40. So our discriminant is b squared minus 4ac, which is 6 squared minus 4 times 1 times negative 40. When we evaluate that, we get 196. You might not know off of the top of your head if 196 is a perfect square, but you can check easily on your calculator. Take the square root of 196, and you'll see that that is 14. So that tells us that 196 is a perfect square. So at this point, we could solve this equation with factoring, but I'm going to show you how you can get the same solutions by using the quadratic formula. The next step then will be to substitute into our quadratic formula. We've already identified A, B, and C. So to get our solutions, x will equal negative b plus or minus b squared minus 4ac over 2a. So with those substitutions, we get negative 6 plus or minus, and you'll notice that that b squared minus 4ac was the discriminant. So if you'd like to, we can go ahead and substitute the 196 because we've already evaluated that, and then divide by 2 times 1. So here we can simplify this again. We know already that the square root of 196 is 14, and 2 times 1 is 2. We will have two solutions where we take negative 6 plus 14 divided by 2, and where we take negative 6 and subtract 14 and divide by 2. Our first solution, negative 6 plus 14 over 2, we get 8 in the numerator, 2 in the denominator, so our solution is 4. And for our second solution, we get negative 20 in the numerator, divided by 2 in the denominator, we get negative 10. So our solution set here is 4 and negative 10. Our next example, example 2, is to solve 2x squared minus 3x minus 5 equals 0. We are already in standard form, so we don't need to do any work to get it into standard form. So now let's evaluate the discriminant. Our value for A is 2, our value for B is negative 3, and our value for C is negative 5, which gives us a discriminant value, b squared minus 4ac is negative 3 squared. Notice here that I am putting negative 3 in parentheses to remind myself that negative 3 is going to be squared, minus 4 times a times c. Negative 3 squared gives us positive 9, and then 4 times 2 times negative 5, we are going to be evaluating 9 minus negative 40, which equals 49. You might know this perfect square, but if you don't, take the square root of this. The square root of 49 is 7. So we know that we will have rational solutions. So now let's plug into the quadratic formula. Our solutions will be negative b plus or minus b squared minus 4ac, all divided by 2a. We've already identified a, b, and c. We will have a negative of negative 3 plus or minus the square root of 49, again using the discriminant that we've already evaluated, divided by 2 times a. So now when we simplify this, negative of -3 is +3, and the square root of 49 is 7, so we'll have plus or minus 7, all divided by 4. So for this equation, the two solutions will be x equals 3 plus 7 divided by 4, and x equals 3 minus 7 divided by 4. So if we simplify this, we will get 10 over 4, which can be simplified further by factoring out a greatest common factor of 2. And so this simplifies to 5/2. And our other solution, 3 minus 7 divided by 4, you get -4 over 4, which simplifies to -1. This makes our solution set 5/2 and -1. Now it's your turn to try one of these equations. I would like you to solve 4x squared plus 8x plus 7 equals 4. Pause the video now, work this solution out on your own, and when you come back, I will show you what you should have gotten for your solutions. For this equation, you should have gotten the solution set -1/2 and -3/2. If you did not simplify your answers, that's okay. You would have gotten -4/8 and -12/8. Those are what's called equivalent solutions. Both of them are acceptable, but if you got the second set of solutions, you should probably try to simplify your answer by dividing out a common factor. So if you got those answers, great job. If you didn't, you might want to go back and watch the previous two examples to find out what you did wrong and then try to solve this equation again. Thank you for watching. I hope that you now feel comfortable with solving quadratic equations that have rational solutions.